In this video, we're going to look at the modulus argument form of a complex number and the Cartesian form of a complex number. Before we actually start, we need to look at one or two preliminary results. If we take cos of pi minus alpha, using our addition formula, this gives us cos pi cos alpha plus sin pi sin alpha, and cos pi is minus 1, which gives you minus cos alpha. Sin pi is 0, so that disappears. Sin pi minus alpha, sin pi cos alpha minus cos pi sin alpha, sin pi is 0, cos pi is minus 1, which gives us plus sin alpha. Okay, now we are ready to look at the first case. We're going to look at the situation where 0 is less than or equal to arg z less than pi by 2. So let's suppose that we start with z equals x plus iy with modulus r and argument theta. Then we have r theta, and we are at the point x, y. Right, let's move that up a little bit. Now, a little bit of simple trick will show us that if we take the x coordinate, if we take the x coordinate, still not very straight, that the x coordinate is r cos theta, and that the y coordinate is r sine theta, and so z equals x plus iy equals r cos theta plus I r sine theta. Okay, that's all very easy. Let's have a look and see what happens if we take z, or the argument of z, to be obtuse. Pi by 2 less than arg z less than pi. Here we go the same way. We take z equals x plus iy, and the modulus of z is r, and the argument of z is theta. So the modulus is r. The argument, remember that the argument is the angle made with the positive x-axis. So the argument is this angle here. And that one I'm going to call alpha. Now I want to look at two distances, that one and that one. Let's suppose that this is P, N, and that obviously is the origin O. Then, if we look at, let's just move that fellow a little bit. That's better. If we look at ON, that is R cos alpha. And if we look at Pn, that is R sine alpha. So the x coordinate of P is minus ON, that is minus R cos alpha. That is equal to R times minus cos alpha. Can we remember our preliminary result that minus cos alpha, whoops, let's do that again, minus cos alpha is the same as cos pi minus alpha. Minus cos alpha is the same as cos pi minus alpha, and in a moment we'll be using sine alpha is the same as sine of pi minus alpha. So minus cos alpha is the same as cos pi minus alpha, which is r cos theta. The y-coordinate of P is r sine alpha, and I reminded you that that was the same as r sine pi minus alpha, and that is just r sine theta. So we have the same result, z equals x plus iy equals r cos theta plus I sine theta. And this result is true for all values of theta. Z equals x plus iy is called the Cartesian form, and z equals r cos theta plus I r sine theta is called the modulus argument form. And now let's have a look at an example or two. Let's suppose we take this one, write z equals minus 1 minus I root 3 in mod arg form. Let's just take this and move it across the page a little bit. Minus 1 minus I root 3. Well, we need to look at this angle first, which is alpha. If this is minus 1 minus I root 3, then the horizontal distance is 1. The vertical distance is root 3, and therefore tan alpha is equal to root 3, and that gives us that alpha is pi by 3. Remembering that the argument is the angle made with the positive x-axis, the argument then is going to be that angle is going to be negative, so my argument theta is going to be arg z is equal to theta, which is minus 2 pi by 3. If alpha is pi by 3, I need an angle of 2 pi by 3 to make up the straight line. Minus 2 pi by 3 will be the argument. And so now, writing it in modulus argument form, z is equal to, except that we haven't yet worked out the modulus, so let's do the modulus of z. Modulus of z is the square root of 1 plus 3, which is 2. Z now in modulus argument form is going to be 2 cos minus 2 pi by 3 plus I 2 sine minus 2 pi by 3. So there is the modulus argument form for that complex number. Okay, another example. Let's move this across a little bit. Right, z equals 5 cos 5 pi by 6 plus I 5 sine 5 pi by 6 in Cartesian Well, this is easy. All that we need is that cos 5 pi by 6 is equal to minus root 3 over 2, and sine 5 pi by 6 is equal to a half, and just plug it in and we get that z is equal to 5 times minus root 3 upon 2 plus I times 5 times a half. And that is the Cartesian form. Let's just make sure that looks sensible. Let's have a look and draw something which is approximately minus 5 root 3. It's about minus 4.3 root 3. Let's have a look at that. So minus 5 root 3 minus 4 plus 2.5. So there we are, very roughly. That would be about minus 5 root 3 upon 2, which is about minus 4.33, plus 2.5. And you can see that the idea that the argument should be 5 pi by 6 is really quite sensible. Now we move on. One more little result to do, and this is what happens when we multiply complex numbers in mod arg form. Well, let's have a look. Let's take Z1, Z2, where Z1 is the number with modulus R1 and argument theta 1. And Z2 is the number with modulus R2 and argument theta 2. Multiplying those together, well, there's an R1 in common, there's an R2 in common. Let's take the R1, R2 out. Then we're left with, if we look at multiplying this out, we will get cos theta 1, cos theta 2. And then the other part of the real bit here is that if we have the last two, we get I times I is I squared, that's minus sine theta 1, sine theta 2. So minus sine theta 1, sine theta 2. Plus, well, the next two have both got an I in, so let's leave that out. We've taken the R1 and the R2 out. We get sine theta 1 times I times cos theta 2. So that's I times sine theta 1 cos theta 2. Plus, and looking at the last pair here, we've got the outside pair, cos theta 1 times I sine theta 2. We've taken the I out, so that's cos theta 1 sine theta 2. Now we get a big bonus. We've got the first one is cos theta 1 cos plus theta 2, cos theta 1 plus theta 2, plus I sine theta 1 plus theta 2. Sine cos plus cos sine. And this is a complex number, and here we've got that mod z1 z2 is equal to r1 r2, which is mod z1 times mod z2. And also we've got that arg of z1 z2 is, here it is, the argument is theta 1 plus theta 2, theta 1 plus theta 2, and that is equal to the argument of z1 plus the argument of z2. So we have a nice little result at the end there, that if we multiply two complex numbers together in modulus argument form, we multiply their moduli and we add their arguments. Example. Find 3 cos pi by 4 plus I sine pi by 4 times 5 cos pi by 6 plus I sine pi by 6. Well, this is not too difficult. It obeys the rules above. We're multiplying two numbers together. The first number has modulus 3, the second number has modulus 5, and so the product of those two numbers will have modulus 3 times 5. Now we need the argument. When we multiply two numbers, we add their arguments. Pi by 4 plus pi by 6. That's 3 pi by 12 plus 2 pi by 12. And so my argument is 5 pi by 12 plus I sine 5 pi by 12. Sorry about the pause. I had forgotten what pages this was in the book. You'll find all of this in your textbook FP1 on pages 19 to 21.